Yeah, so today I'm going to talk about artificial intelligence for Simulink. My name is Christine Bolliger. I'm an application engineer working for MathWorks in Switzerland. So artificial intelligence for Simulink, that means I will tell you how you can incorporate AI algorithms in simulations and also deploy them to embedded targets, for instance. Let's start with an overview. Here we have an overview of a system level model. We have a plant model of our product, and we have ways of sensing how that plant behaves. And then based on some logics, we can make some planning and control what we want to do next. So it's a really high level overview of a system level model. Now, in all these steps, we can incorporate artificial intelligence for some tasks. Like for instance, in the plant, so if you want to simulate the plant, we could use a reduced order model, which is the act of reducing the complexity of a model, typically a high fidelity physics-based simulation model. You can do that with in different ways, but you can also use AI for this. This is one example. Another one is for the measurement or perception part, where you can replace a sensor, a physical sensor, with a virtual sensor. We will see why you want to do that. And we will also look at this example more in detail later. Then you can use reinforcement learning for controls and decision-making applications, which is a method where the model trains against the simulation environment. And this type of AI can be able to learn complex control situations that could be difficult to control with traditional models. Then we have a fourth application, which is more of the other way around than the previous three ones. We saw reduced order modeling, virtual sensoring, sensor modeling, and reinforcement learning, which are all tasks that you can incorporate into the simulation. But the fourth one, data synthesis, is kind of using simulation for AI. So you can use the simulation to generate data and then use that to train an AI model. So this is like a special case, but these are the four trends that we are observing where AI with model-based designs is combined. So MBD, that's model-based design. So why do we observe these trends? Because they help you to overcome common challenges. Like, for instance, your models, which can be very complex, or your algorithms are too slow to run in real time. And in some situations, they need to run in real time. Or the models are unnecessarily complex for what you are going to use it for, and the simpler black box AI model is sufficient. Or your models might be inaccurate, so they don't really depict the truth, and you're looking for a way to remedy that. For example, if you are calculating exhaust emissions, then an AI model can actually be more accurate than a very high fidelity model. So if you train it on real data. Or it could be that you are interested in a measurement that's difficult to obtain, which you can remedy by generating them synthetically with simulation. First example or trend we're going to look at is reduced order modeling. So why? So you want to create a faster and more lightweight model of the high fidelity physics-based models for tasks when speed is more important than accuracy. And how can you do that? It's by training on simulated data from the high fidelity model or real data. So you could combine also real data and simulated data and train your AI model on that in order to generate a reduced order model. One example we could think of is engine torque estimation. We have tested that ourselves. So we want to replace the high fidelity engine model inside the plant model of the car with an AI version to speed up the plant simulation. And the result was that the engine model runs 10 to 50 times faster, and the overall simulation runs about 2.5 faster. And like that, we could speed up the model to get real-time simulation. So the AI model took as an input the engine speed, the ignition timing, the throttle position, the wastegate valve, and the output was the engine torque. Here, this is a symbol for the neural network that was used, so the AI model that was trained. Here we have a real-life example here as well. You can read about this on our website. Here's the link. You will get the slides later. Where Renault used deep learning methods, models to estimate the NOx emissions. And in the end, the results were that the NOx emissions could be predicted with close to 90% accuracy. And the LSTM, so that's the long short-term memory network, was incorporated into the after-treatment simulation model. And they could also generate code directly from the network for the ECU deployment. The second trend, data synthesis. So that's the one which is a little bit special, where you generate data for AI models. Could be, for example, here, where we have a, and why would you want to do that? Is when data is hard to get through lab tests or otherwise. And how you can do that is like repurposing existing simulation models and use digital twins to generate data to train better AI models for application deployment. So, for instance, you could simulate fault data with digital twins. And if you look at the predictive maintenance use case, we need to alter the models a bit to include faults. So here is the full simulation. And here we have the valve outlet that we can change with the parameters. So we can see how different faults will, in the end, have an impact on the measured data. So here we made simulations with different leakage areas. So if this area is high, then you have a leakage fault. So we can simulate that. Or the bearing friction. So with a high friction, you get a fault, like a friction fault, or also by varying the blocking parameters, you have different faults there. And here you can see how the output pressure then depends on these input parameters from the simulation. So like that, you will get a large data set with flows and pressures and the corresponding fault code. So you could, in the end, use that to train an AI model that can predict fault codes based on the measured data. There's also a real-life example for that, which you can read up on our website, which is about an automated beverage packaging system where they incorporated a dynamic tripod robot into the design.